Hello, welcome to the June edition of the Nutritionist webinar. I am Marianne Fessenden from Agricultural Modeling and Training Systems and serve as your American host. The purpose of these webinars is to provide access to technical seminars delivered by internationally recognized speakers. The series is a unique three-language presentation held in English, Portuguese, and Spanish. Noted ruminant nutritionists will present in English, hosted by AMTS in the United States, while Marcelo Hens Ramos from 3R Lab simultaneously translates into Portuguese for Brazil, and Paula Torillo translates into Spanish for Argentina. There will be a post-presentation question and answer period during which listeners can submit questions through me or Marcelo and Paula. During this month's presentation, we will break to conduct 4 audience polls, the result of which will be discussed during the question and answer period. A complete recording of archived webinars as well as the question and answer session for each will be available on the 3R Lab and AMTS websites. For this, our 5th webinar, we are very pleased to welcome Dr. Noelia Silva-del-Rio, who is the Cooperative Extension Veterinary Medicine Dairy Specialist at the University of California, Davis. Noelia obtained her veterinary medicine degree from Universidad de Santiago de Compostela in Spain and years working for a dairy cattle cooperative in Spain. In 2007, she completed a PhD in dairy science from the University of Wisconsin-Madison, where her concentration was on dairy cattle nutrition and reproductive physiology. Dr. Silva-del-Rio served as the dairy advisor for Tulare County through the University of California Cooperative Extension from August 2008 to February 2012. She now serves as the Dairy Extension Specialist for the Veterinary Medicine Teaching and Research Center at the University of California, Davis. Dr. Silva-del-Rio's research includes research in feeding management, silage management, lameness, and periparturient health problems. Dr. Silva-del-Rio, we are very glad you were able to join us. I will turn the mic over to you and enjoy your presentation.
Thank you very much, Marianne, for your introduction. I hope you can hear me. Thank you very much for your introduction. The title of my presentation today is going to be Feeding Process, Variation in TMR Preparation and Delivery. Before I start, I'm going to do a brief introduction again, Marianne. So as you said before, I finished my DVN in Spain in the year 98. And after that, what I did is to practice for 2 years as a technical service for Corever, that is a small farm co-op in the northwest part of Spain, where I did reproduction and milk quality work. After that, I moved to the United States. I wanted to improve my education, so I ended up doing a PhD in Wisconsin. And my focus was on reproduction and nutrition. I worked with Dr. Rick Grammer and Dr. Paul Fricke. And the title of my thesis was Epidemiology, Physiology, and Nutritional Management of Twinning in Holstein Cattle. And in August 2008, I started my job with the University of California Cooperative Extension in Tulare County. For all of you that maybe are not familiar with Tulare County is the #1 county in the United States. We have 500,000 dairy cows producing. And then if we add the dry cows and the replacement heifers, we probably are close to 1 million animals just in this county. After that position, I moved to the Veterinary Medicine Teaching and Research Center. That is one of the satellite units that the School of Veterinary Medicine in Davis has. In this center is where the students come to do large animal practice. And we also have a milk quality lab and a diagnostic lab. And I'm very happy to be located here because I'm very close to a lot of dairies and I can do a lot of research. So my responsibilities as a vet med dairy extension specialist is to implement a research and education program for veterinarians, producers, and allied industry. And the topics that I'm focusing my work are hypocalcemia prevention, feeding management, judicious use of antibiotics, and lameness. So the student that worked with me on this project of feeding management, her name is Yolanda, and I just want to share some pictures of her working. And you can see here, she's here and also here. She did two studies. The first study was feeding management practices on farm assessment. And the objective of this project was to develop a systematic approach to identify opportunities in feeding management. And what we did is to visit days, and we observed the feeding management practices that they were going on. We evaluate the missing equipment. We analyze the total mixed ration, interview feeders, and also analyze the feeding management software data. And for this assessment on farm assessments, we just use 1 month data from the feeding management software. And we also did a second project, and the second project is an analysis of variation of TMR preparation and delivery. And the objective of this project was to describe industry practices based on records from feeding management software. So we collect 12 months information from 26 dairies in California from the feeding management software, and the size of the herds range from 600 to 6,000 cows. I'm just going to briefly explain what is a feeding management software, because there might happen that some people in the audience, they don't really understand it. And a feeding management software, here we have a central computer where the nutritionist or the manager can enter the recipe that it has been formulated by the nutritionist. And then this information goes to a screen that is on the tractor that is driving, or truck that is driving the feeder. And he has a menu where he can choose what recipe he's going to prepare. And then the software is going to indicate the amount of the different feeds that he needs to add. So it really makes the job of a feeder much easier. And if they input, as they should, input the number of cows when there are pen movements, it should be, they don't need to do any calculation as when you go with the papers and do the on-site calculations based on the number of animals that you have per pen. So are feeding management practices important? And I imagine all of you that are attending this seminar think that they are. And my question is, why? Well, inadequate feeding management practices on dairies can result in an increased number of health events. And we have some examples here: displaced abomination, diarrhea, hypocalcemia, and this might be just a typical case in California because we are feeding pistachio shells. And 2 years ago, we had several cases of pistachio shell impactations because we were overfeeding pistachio shells. So if the ration fed differs from the formulated one, cows will not achieve their maximum production potential, and some nutrients, for example nitrogen, will be wasted in manure rather than converted to milk. So feeding management practices to ensure that the formulated ration and the fed ration are as close as possible are really critical.
All right. At this time, I'm going to, if you'll excuse me for a moment, Dr. Silva-del-Rio, we're pausing the presentation here to briefly conduct a poll of the listeners. This poll has been designed to test the listeners' foreknowledge. Dr. Silva-del-Rio will cover the following slides. I will read a question. You will have approximately 30 seconds in which to record your answer. After the poll closes, we will continue with Dr. Silva-del-Rio's presentation where she left off.
This slide, this is a work that I did in collaboration with Alejandro Castillo from Argentina, and we evaluate the difference in the units of percentage of crude protein between the formulated ration and the analyzed crude protein at the feed bank. We did that on 7 days in Merced County, and if you look here, here we have 1, 2, 3, 4, 5, 6, 7 days, and if you look closely, you can see that there are 2 or 3 bars per dairy, and each of these bars represent different production groups. The first is the high, medium, or low when they have 3 groups, or high and low when they have 2 groups. 0 represents if the dairy was feeding the same crude protein that the nutritionist formulated all the observations should be close to zero, on top of zero. So when we find a deviation from zero, what it means, like in this case, is that particular diet was fed with 2 units of crude protein less than it was formulated. And we will go here to the 87, we can find that this particular recipe was 3.4% units of crude protein above what it was formulated. So if the diet was formulated to be 20%, in this case they were feeding 23.4%, and if in this case the diet was formulated to be 20%, it was fed 80%. This is also another piece of information from Dr. Bob James in Virginia. And they did a study where they collect information from 15 dairies over 1 year, and they did also the comparison between the feed bank analysis and the formulated recipe. And the 1 year observation from the 15 monthly observations from the 15 dairies is represented here in this cloud. So, what do you think? If there is any relationship between what is formulated and what is being fed? Here are the statistics. R 0.45, not statistical significance. And if we look, we are going to check several points here. For example, we have this was to be formulated for 16.8 more or less, and then if we go here, we can see that it was actually fed around 12% crude protein. We can look at this, for example, it was formulated to be close to 90%, and we will go here, actually what it was fed is 15%. And we can go and look at more points, but all of them are going to give you that there were important differences between what it was formulated and what it was fed. So now what I'm going to do is I'm going to introduce 2 case studies, 2 dairies, and I'm going to present information from those dairies and compare those dairies to the 26 dairies that I have information from the feeding management software. So the first dairy that I'm going to talk about is a 4,500 facility, hosting cows, and the orientation of the dairy is north-south. Here we have the milking parlor. Here is the hospital pen. Here is the pens 9, 10, 7, 8, 2, 3, and 4. And all of these pens were fed high cow ration. So that's what they are, we study those pens. The first thing that we do when we go to a dairy is just to walk around and see commodities. And I'm just gonna stop and just remark the highlights that we found. And the most important thing on this data that we found regarding commodities was the green chop alfalfa. And green chop alfalfa, this was, I'm going to repeat it again, it was a 4,500 cow facility. 2 to 3 trucks arrive every day with green chop alfalfa. And the feeder evaluated dry matter daily and updated the feeding management software. He was giving a coaster tester to do the dry matter checking. He told us that he believed he was skilled to estimate dry matter visually at the same time. And I'm just going to show you now how the dry matter looks like. And we got this information from the Feed Watch records. There were 93 observations for the month of July, and each of the dots correspond to 1 observation. So 2 to 3 dots belong to the same day. So what do you think about this data? The first thing that is probably striking you is that this is 40% dry matter, 80% here. So you can see that this is actually a very high dry matter green chop alfalfa. And the second thing that you probably can notice is that this is going up and down throughout 1 month. So does anyone here want to feed this? These are 10 grab samples that we took from 1 pile. And I just want to pay attention and look at them. These are, they were taken the same day from the same pile, different locations within the pile, but you can see something that is that different grab samples look different. So this indicates that there is a problem coming from the field. The crop manager in this operation probably could improve his performance. What we did is take 10 samples on August 29th, September 5th, and October 11th. And of those 10 samples that we grabbed, we did triplicates of dry matter, and then those are represented in the blue dots. So we have here 10 blue dots that represent the 10 dry matters that we took. And the red represents what it was registered on FeedWatch, and on green, the mean of the blue dots. So now we can see here that this is the day that we did our assessment on August 29th. So you can see that there was quite a difference between what it was on FeedWatch and what it was fed. We also can see here there is a huge variation within the blue dots. We have a coefficient of variation of dry matter for that particular date of 8.9%, following the 22.2%, and the next one 22.6%. So it's quite variable. So how this is going to affect the results of the wet chemistry? So we have the crude protein of the formulated ration is here, and here is the results from the feed bank. And we can see that the crude protein was lower compared to the formulated, but there was an important difference in fiber content, ADF and ANDF. One thing that I want to mention here is that the feeder at one point confessed to us that the scale that he needed to use for the coaster tester was stolen, so he was not doing coaster tester, number one. And the other thing that we learned when we visit this facility is that the owner of the facility plays golf with the owner of the costume harvester company. So the conversation about what is happening at this fields of alfalfa has never taken place and is not in the agenda of the dairy owner, because he doesn't want to start a conflict with this person that he has a relationship with. So there are two issues here. The feeder is not checking dry matter, and I think the most important one is that there is a problem coming starting at the field, managing the alfalfa crop.
We often talk about that in the office here, how different the fed ration is from the formulated ration based on just plain human error. We're going to break again for a poll.
So how often do you evaluate silent dry matter? This is a question that we posed to dairy producers in California in 2010 in collaboration with my colleague Jennifer Hagig. We did a mailing survey, and we got 120 responses back. Of those, 101 replied to this question. And based on this data, we found that consilent dry matter was conducted at least once a month in 52.3% of the dairies, but only 8.3% of the dairies did dry matter weekly or more often. And most dairies delegated dry matter determination to an outside nutrition consultant, 86.6%. But how often should we check dry matter? And I found this webpage from the University of Wisconsin. They have recommendations of frequency of sampling based on her size. And you can, depending on you have 50, 100, 200, 400, 800, or 1,600 cows, you can check here how often do you need to take your samples. If you have 1,600 cows, it is recommended that between sampling is 4 days and per month around 7. Also, the frequency of dry matter determination should increase when we find that the dry matter varies too much in between samplings. In case of extreme weather conditions, and we have to think especially if you are in a climate where it rains a lot, if there are changes in silage appearance, if you end up finding a spot in your silage, so you probably need to check that. And of course, whenever you start a silage and when you're ending the silage, you need to be more on top of the dry matter, because it's when we have most variation. So now you get the results, and what you should do. Should you change every time that you get a new result, or you should be a little bit more considerate because sometimes there might be an error? So if you get a difference in 3 units of dry matter, the first thing that I will recommend is just to do the sample again, because this is a very significant difference, and also go and evaluate the silage appearance to see if it matches the results that you are getting. if over a period of 3 consecutive days you are getting that your silage is consistently 1 unit below or above the previous results of dry matter, then it's time to change the dry matter of the forest. And St. Pierre and with 2007 they recommended to use the weight average, so the more recent result should have a weight of 50%, the second last result 30%, and the third last result 20% of the weight. Now we are going back to our dairy number 1, loading ingredients. The other thing that we check on this dairy is the front-end loader position, and we evaluated that on 4 recipes. 2 were premix, high-carb premix, this one, and on we did that in 6 recipes. 2 were premix recipes and 3 were high-carb recipes. So we can see here that we have 3 bars because we did 3 times this recipe and 3 times this recipe. We check if the recipe was delivered on the front, on the middle, or on the back of the mixer wagon. And we can see here in this picture where they are delivering whey, and it's a little bit, the mixer wagon is a little bit, is getting the whey on the back. So we can see here whey here, 2 times it was on the back for the premix, and 1 out of 3 times was on the back for the high-carb recipe. So in this case, in the evaluation that we did on that particular day, 50% of the time whey was towards the end of the mixer wagon. And why this is important? Well, this is the last ingredient in both recipes, and what it happens is, as it should be, because it's a wet, moisture, high moisture ingredient, and what is going to happen is it's going to stick particles together. But we want to have it in the middle to ensure that the mixing is uniform and is happening evenly throughout the mixer wagon. But what can happen when we do this and we have one wet or high moisture water, molasses, whey, on one side of the mixer wagon, we can actually affect mixing uniformity. The other thing that we saw at this particular dairy, when we were watching them how they were preparing the high-carb recipe, is that even though it was not registered on the FeedWatch records, the first ingredient added was a feed additive, 50 pounds. What they did is they opened a bag of 50 pounds, empty it on the front-end loader. The next step is the feeder went to pick up canola, and then both ingredients, they were added into the mixer wagon. And why do you think he is doing that? He's doing that because he needs, probably the manager told him that this feed additive needed to be one of the ingredients of the recipe. And the most convenient time to actually add this ingredient into the recipe is at the beginning, because otherwise he needs to get down on the tractor, open the bag, and do this. So that is probably why he's choosing to do this as adding a feed additive as first ingredient. And I thought this probably, I was scratching my head when I saw this, but I was pulling my hair when I saw this. So this is the leftovers. Most of these that you can see here are leftovers from the previous recipe, and they just added the first ingredient into the new high-carb ration that they are preparing. And these is the ingredient that they added. This was a 50-pound feed additive that it was caked, and that is the first ingredient that is added. He climbs up to the mixer wagon and just opens the bag there and drops the ingredient. The next thing that he did is take another bag, open it up, and another 50 pounds of a different feed additive. So, do you think that it's worth to invest the money on these feed additives?
Thank you, Dr. Silva-del-Rio. We'll pause again for the third of our 4 polls.
So ingredient order. So what is the best ingredient order? So we need to consider for that the physical properties of the ingredients that we are adding. We have the particle size, the shape, density, hygroscopicity, static charge, and a head seed. So when we add ingredients that are sticking together, like xylase, molasses, fat, when should we add those into the recipe? And I use this example with feeders, like pretend that we are going to bake something, although most of them probably are not baking anything. But if we were to bake anything and we have these ingredients, flour, sugar, yeast, and oil, we should start with flour because it's the ingredient that is the largest one, and then sugar is the second in quantity, and then yeast. And then we mix those ingredients together, and it's quite easy to mix those ingredients because they have very similar shape and size. And last we add oil. But what will happen if we decide to change the order of ingredients? If we put first flour and then oil, and then we add sugar and yeast, how do you think the sugar and the yeast are going to mix in that? The ingredients ordered into, when we consider the ingredients ordered into the mixer wagon, we need to consider also the density. When we are adding dense ingredients, like for example minerals, they go down, they sink. Minerals high density ingredients. When we add low density ingredients, they float, they go to the top. So there are going to be difference when we should add all of those ingredients depending on density. What will you add first, corn silage or alfalfa silage? And I'm going to give you a tip. Corn silage is 33% more dense than alfalfa silage. What it means that corn silage is going to go down faster or easier than alfalfa silage. Alfalfa silage is going to be less dense, so it's going to try to float. What we add first, the grains or the minerals? And minerals are 2 to 3 times denser than grains. So in this case, we will choose first, in the first case, we will choose first to add the alfalfa silage and then the corn silage. And in this case, we choose to add first the ingredients that are dense, the less dense, that are grains, and then go to the minerals. Here what I have is a slide that shows the order of ingredients that the dairy producers in California chose. This is based on a survey that we did. Again, the mail surveyed 120 people. So the first ingredient, hay, most of the dairy producers replied that it was added as a first ingredient. When we go to silage, you can see, and here we have the vertical mixer wagon, and here the horizontal mixer wagon. So for silage, you can see that the pattern was similar also for both vertical and mixer wagon. For grains, again, we see a similar shape between horizontal and vertical mixer, and then last minerals and vitamins. And you can see that each dairy has a different pattern of order of ingredients. And you can see that it is not a consistent pattern that minerals are added last or silage are added always as a second ingredient. So there is a variation of the order of ingredients across dairies. But the thing that it was consistent is that hay was the first ingredient added in most dairies. Protein is again here, and the same thing that we have seen for the other ingredients. Variation across dairies, and there is not a clear pattern if it goes second, third, or fourth position. Now I'm going back again to dairy 1, time between ingredients, and we are going to evaluate on this dairy the number of observations that the time between ingredients, loading ingredients, was short, and the time between ingredients that it was long. What are the implications of loading time between ingredients that is short? Well, short time between ingredients, what it indicates is that the feeder is dropping leftovers of the previous ingredient as the new ingredient. And I found here some dairies where this was enough reason to fire a feeder. We also find that some feeders, what they are doing is that they take the leftovers from the previous ingredient and load the next ingredient. And the reason because they do that is because they learn that they can be caught if they cheat. So this gives them a little bit more time. They don't go back and return the feed that is left to the commodity barn, but they still look pretty good on the computer records. There are also times where we can find long time between ingredients, and it could be because the feeder needs to stop, find the seeds for the commodities that are being delivered, or maybe also in some occasions some commodities like silas are stored very far apart from the commodity area and they need to do a long drive to get there. I should now add a third reason that I just recently found, and is in one data that we are just studying now. This day, the feeder is taking too long between ingredients because he is cleaning after he loads one ingredient. He goes back to the commodity barn and just with the front end loader, just try to clean the commodity and put it back again. And we learned also that the feeder is getting paid by the hour. When we did this study, we actually got some notes from the dairy producer telling us that the feeder was, on that particular day that we were visiting with him, he put too many hours and he had to pay overtime, and he didn't want that to happen again. So we are under the suspicion that the feeder is actually trying to elongate the time between ingredients just to have more hours at the end of the day. So here in this slide, we have loading time between ingredients, and we observe several dairies to see how, we need to establish a cutoff point. What is short time versus unacceptable short time versus unacceptable? We explore the 45 seconds cutoff point to see if any feeder could just load one ingredient, finish loading one ingredient, and get the next ingredient in less than 45 seconds without cheating. So what we did is to all the dairies that we are doing this assessment, we are standing there and timing them when they finish one ingredient. So in this day, the first ingredient that was added in the high carb recipe was the alfalfa green chop. And here we have the time that we observed that time when we were watching him doing this operation. And based on our timing, it was 50 seconds that it took him to finish the alfalfa green chop loading to loading premix. And you can see here we have number one is alfalfa. This is where the location of this ingredient. Number two, premix is here. Number three, it will be energy 2 here. Number four, cottonseed. Number five, corn silage. And number six, almond hulls. And then the whey will be located here, 7. So we found that between alfalfa and premix, it was 60 seconds. Between premix and energy 2, 60 seconds. Between energy 2 and cottonseed, 55 seconds. Cottonseed and corn silage, 150 seconds. And then 90 seconds and 80 seconds for the other ingredient. These numbers, the percentage that I have here in this column, what they represent is the number of times that we found that this time, the time between alfalfa green chop and premix, was under 45 seconds on this particular day, 1 month prior to our evaluation. It was 22.8% for this ingredient, 72.5% for between those two ingredients, 16.7% between those two ingredients, and 3.7% between those two, and 34.9% here, and 6.3%. So I'm going to go back one slide now to the previous slide, and here I'm going to show you what happens between premix and energy 2. I move again one slide just to remind you where those are located. So here we have the premix number 2 is here, and energy 2 is here, number 3. Back again. So it took, our observation was 50 seconds, but what it was registered on the computer is that most of the time it was less than 15 seconds. And actually 72.5% was under 45 seconds. So what can explain that? Probably what is happening here is that he's probably jumping, loading both ingredients, premix and energy 2 on the same load, and he's jumping to the next ingredient. So at the end, he doesn't allow enough time, and we can catch him here in the less than 50 seconds. He probably, I'm sure that he doesn't know, he didn't know about that we could check this. Otherwise, probably what he will do is just wait a little bit longer than 15 seconds, because 15 seconds is actually very obvious that they are cheating. And the feeders that they know, they try to work some things around, and so sometimes it's hard even to catch those things. So the frequency of loading time between ingredients less than 45 seconds is represented here for the three feeders that were operating in this facility. We have the primary feeder, the relief feeder, and the sporadic feeder. And this is the total number of recipes that were evaluated in that month prior to our visit that we analyzed. And you can see here that for the primary feeder, he's doing it 20% of the time. And the relief and the sporadic feeders seem to be doing that more often. Now my question to you is, how do you think this data is actually doing? Is average, or do you think that 20% it will be average among all the data that we are finding, or do you think that this is something that makes this data stand alone? In this figure, we have the 26 data points from 26 days. The days are assigned one number, and the number 1 belongs to the data that is the largest one, and the number 26 belongs to the smaller data. So the number actually gives you an idea of her size. And what we have here is a representation of the median time that for 1 year. Each of these bars contains information for a 12-month period. So the number of observations that they were between 0 and 15 seconds, between 15 and 30 seconds, and 30 to 45 seconds for the different dairies. So here is our dairy, dairy number 5. Suddenly it doesn't look that bad, because look at this one, dairy number 7. In this particular dairy, 30% of the times, ingredients are loaded with less than 50 seconds. Roughly 70% the ingredients are loaded with less than 40 seconds time between ingredients. So what is probably happening on this dairy is that the feeder is not going back and putting back leftovers from the previous commodity into the commodity barn. What he's doing is adding those as the new ingredient. We also try to check the measure wagon. We evaluate if the scale is calibrated or not. In this particular dairy, the measure wagon scale was calibrated. And I believe one of the reasons is because the manager attended previously some of the seminars that we have put together, and we emphasize also the importance of calibrating the scale, and he was doing that, so he was able to have a measure wagon properly calibrated. We also check the bouncing of the scale, because when you're loading ingredients, the feed is moving, and there is not a constant weight that you are reading, because the weight moves into the mixer wagon and moves from one cell weight to another one. So you can get different readings during the loading. And what we identified in this area was that there was a bouncing from 15 to 80 pounds, and this was a 3-over mixer wagon. I don't know if that is the explanation, but in this particular dairy, 80 pounds is the highest that we have found in other dairies. Other dairies that we have checked, we don't go over 40 pounds. But the other dairies that we have evaluated, they were 2 others. So I don't know if the 3 versus the 2 has something to do. Another thing that I want to mention is that also some of the dairies that we are evaluating, in one particular dairy, we found that the measure wagon was 1,500 pounds off, so it was not calibrated. There are also, in this particular dairy, they were having issues with cleaning out the measure wagon, and you can see here the premix. There were 1,000 pounds of premix left in the measure wagon, an estimate value of $100. And so we check, okay, you have this leftover, who is getting this leftover? And we check, and most of the times the premix leftover goes back into premix, and in 35% of the times it goes to high carb recipes. So in this regard, at least, it was used for high producing animals. A small number of times it was ended up added to the low producing animal recipe.
Okay, I'm interrupting for a final time, and we're going to do the last poll.
So in the male survey that we did in 2010, we also asked the question, how often do you check your mixer box is calibrated? And 79% of producers, they reply that they check the mixer scale at least once a year, but only 90% check it at least monthly. The mixer wagon was calibrated by an outside service provider or an in-house employee. Now we are going to move to weight deviations from target, and I'm calling it weight deviations from target, but probably what you have in mind is errors. But there are two types of deviations from targets, and that's what I want to differentiate, feeding errors versus deviations from target. So the deviations from target can be due to feeder errors and also to deviations associated with the tolerance level. And I'm going to explain you what is tolerance level. The tolerance level, here is one copy of the screen of the feeding management software. So you want to know the tolerance level of the ingredients that you are feeding. You can go here to inventory, let's say for example forest now, and then you have here the menu with the different ingredients that are there, and then here it gives you what are the tolerance level set for this particular day. So tolerance level is the pounds below the formulated target assigned to each ingredient to avoid overloading. During the loading process, the mixer wagon scale indicates the amount of feed left to reach the formulated target, but when the tolerance level is reached, the software moves onto the next ingredient after a certain period of time. If it's not reading any more new ingredients getting into the mixer wagon, just jumps to the next ingredient. So what actually really means the tolerance level? So the dairy that we are now evaluating, dairy number 1, this dairy has a tolerance level for corn silage of 300 pounds, and here is 300 pounds, so 0 is the target. Here is the target. Now we have a tolerance level of 300 pounds. The message that this feed is getting is that after here you are fine. You don't need to get to 0. You are fine here after here. So barely he gets close by 0. Most of the times he's loading corn silage below 0 just because he's allowed based on the tolerance level of this particular day. I'm going to use box plots now, and I'm going to try to explain you a little bit how we use box plots and how you can read a box plot. And the spacing between the different parts of the box indicate the degree of dispersion and squareness in the data. The middle line of the box here represents the median. The box actually represents 50% of the data, and so here, the area that is here, we have 25% of the data. If we now consider all of this, 50% the box and 25% of the end of the box plot, 75% of the data are here. And now, after the whisker, we have 10% of the data, 10% here and another 10% here. So if we consider all the data from the whisker down, it will be 90% of the observation. What I have here are the different ingredients that they were added in the high-carb recipe for this particular day. We have alfalfa green, premix, energy 2, cotton seed, corn silage, almond hulls, and whey. And the tolerance level is in blue. 300, 100, this is our pounds. 100, 150, 300, 150, and 200 pounds. And 0 is the target that it was supposed to be. This is if the observations falling on 0 were observations where the feeder actually met the target. But you can see that most of the time, the feeder didn't reach the target and was below the target. So if you want to know the deviation allowed by the tolerance level, just look at this. They are in red, expressed as a percentage. So 4.4 for alfalfa green, 1% for premix, energy 2, 62.5%, 14.3% for cotton seed, corn silage, 2.6%, almond hulls, 8.1%, and for whey, 7.5%. So what is an acceptable deviation from target that you think is okay to have? Because you are already introducing an error just by the tolerance level. This figure represents the deviation from target for the various feeders, the primary, the relief, and the sporadic. And they were 2.7%, 3.1%, and 2.6%, and here is the 0. So you can see that all the times they were below the target. So this figure now, here, what it represents is the 26 days that we are always going back to them, when we did the first study. And we have here number 5 is the data that we are studying, and you can see here is the 0. And then you can see here now that the data 5 is below the target, and that is just because of the tolerance level that is pushing this figure to never reach the target. Interestingly, we have data number 1 here. You can see here that this data, the box is quite close, is center, is very close to the 0, is in the middle of the 0. Both dairies actually are from the same dairy owner. They have the same manager and they have the same nutritionist. They have the same recipes also. So why this dairy 5 doesn't reach the target and dairy number 1 reach the target? And this is actually because the feeder on dairy number 1 is actually is not using the tolerance level as the target. For him, his target is just to get close to 0. Those two lines that I have marked here represent a 2% error, either negative or positive. And the reason because I did that is when I ask around what is an acceptable error on your facility, most of the times people respond to me that is around 1, 1.5, or 2%. So just to be liberal, I give 2% error. And you can see that just looking at this figure, there is quite an opportunity for if there is room for opportunity. Looking at the number of observations that we have here above this line and also here below this line. The deviation from target here that I'm presenting is I'm expressing it as a percentage of error as a percentage. But I wanted you to look at data number 4, is the last one. It's a 5,000 dairy facility. Now is the error in this facility as a percentage, but let's look at it as a kilograms. Here we have the figure in kilograms, and here is the same figure that I showed you below, but I just want to put both figures together so you can compare. So before, when we were talking about percentage, this dairy was here and didn't stand out from the other dairies, but when we express the results in kilograms, we can see this dairy actually is the one with the largest room for improvement of all the dairies that we are studying here. So why is this happening? Why percentage doesn't tell us the same thing as kilograms or pounds or whatever you want to use as your unit? And the reason is because they are a large dairy and the error gets diluted by the denominator, that is the size of the mixer wagon. So if you actually want to have a good feeder, you need to evaluate his performance in kilograms. That's the only way that you're going to know if he's good. You also cannot ask a feeder to be better than another one based on percentage using when they are feeding using different equipment and different size. So I will strongly recommend to evaluate the feeders based on kilograms that they deviate. Percentage probably will help you to have an indication of the implications, that the deviations that you are having from the formulated recipe. But to do interventions at the feeder level, you should use pounds or kilograms. Let me go back one slide more, because before, 2 more slides. So now just take a look at data number 3 here. This data is actually what we want. Is all the observations are close together, very close to the 0. So it's accurate and precise. And when I show this slide to people, one of the questions that always comes back is, well, that dairy might be very good at doing it, might be very good at reaching the target, and may be very good at doing it over and over, but that dairy probably is losing a lot of time just doing that. And they are always asking me if that dairy is spending more time preparing the recipe than the rest of the other dairies. So I'm going to move now forward to a slide. So is dairy 3 spending more time to be precise and accurate than are the other dairies? And here what we have is the recipe preparation time. And again, we have a box plotted because what it means is a combination of 1 year observations and like, for example, now we have here dairy 3. So the median time was around 15 minutes that it took to prepare this recipe, and half of the observations were above 15 and the other half of the observations were below 50. But you can see that the time recipe preparation on this day is not bad at all. It's actually good. Really, what it takes time to be accurate or imprecise is just the last, when you are dropping the last pounds into the mixer wagon, that you need to be very carefully moving your front end loader. So what it would be an acceptable deviation from target? And this is a question that we are trying to find an answer. And I'm going to provide some insight based on the database that I have, but I'm being told that if I use a different data set, in particular they told me from Mexico, the accuracy and precision on those data is much better than the one that we have in California. I haven't seen the data, but I had to believe the feeding management software company that shared that information with me. Here, this is an attempt that we did to find what is the best, how we can define a good dairy, a medium dairy, and a bad dairy. And we evaluate precision, and precision was defined as the EQR, interquartile range, and interquartile range, what it means is the size of the box. If we have a box that is very small, what it means is that we are always doing the same thing over and over and over. We have a very long box. What it tells you is that one day you do one thing and the next day you do a different. Then we have the 25 percentile of Q1, and that what it tells you is that you are very accurate. You are getting close to the zero. At least 25% of the times you are able to get close to zero if it's low. And then the 75% percentile, what it tells you is your farthest away from zero observations, how far they are. So the 25 worst observations, how far they fall. And what we did is take all the data that we collected and calculate the interquartile range and try to define some cutoff points that will make sense to the industry. So for interquartile range, we came up with 20 kilograms. It will be a good dairy between 20 to 40 kilograms of interquartile range. It will be more or less, and on dark more than 40 kilograms, it will be really that dairy needs to improve. So when we go now to first quartile Q1, so we have that what it means that is again accuracy. So how close are you to zero? The best dairies actually were able to do it less than 10 kilograms. They were closer to the zero by less than 10 kilograms. So they didn't miss the target by 10 kilograms 25% of the times, either above or below the target. So what it tells you that some dairies are able to reach this target at least 25% of the time. And so you go Q1 is here, and you look at the Y. So all of these dairies, you can see and read the individual values for the different ingredients that we are evaluating here. So for premix, this particular dairy, dairy number 3, deviate the best 25% of the time, just 4 kilograms. So the deviation there is actually very good. And when we go to the observations, the worst observations for dairy 3, they deviate from the zero, just 6 kilograms for premix, 13 for alfalfa 6, 7, 4, 4, and 5. And this was the worst 25% observations were 6 kilograms or more, which is still pretty good. But we are still again talking about dairy number 3. So again, I'm going to repeat this again. Interquartile range, we are looking at precision, and we want to have the box closed. And just check here, dairy number 3, most of the time was very precise, but if we go here to dairy number 4 or dairy number 10, the dispersion of the box was quite huge. You can see it read 49, 90, 128. So one day he was deviating 100 pounds above zero, and another day maybe 70 pounds below zero. That's what it tells you, the interquartile range, the dispersion of the data. Actually, I think interquartile range can tell you much more than any other thing, because if one feeder is able to do the same over and over and over and have a similar error over and over and over, you actually can help him if he's going over the target or under the target. If he's going under the target, it is likely that it's just because he has a high tolerance level for some ingredients. So it would be very easy to move him again to zero, and if he's able to do it over and over the same way, we are going to have a very precise and low error feeder. So in this figure at the end, you can see that we try to classify dairies, and we find that these are acceptable dairies, very good dairies that can serve as an example to other dairymen. And then we have these that are dairies, this portion of dairies are dairies that there are areas for improvement. And these, the last dairies here are dairies that they have issues with getting the feed delivered precisely and also accurately. And what is interesting, you can see here, that if you are white here, what it means you are good, you're going to be good also at everything else, but the dark colors also are in precision, in accuracy, and extreme observations. So basically the data that are good and are accurate are also precise, and they have minimum deviations, extreme deviations from target. Like extreme deviations from target, we can read in this. These are Q3, so these are the worst 25 observations for all these ingredients, for all of these dairies. And you can see here that we are talking about deviations of 118 kilograms, 157 kilograms, 208 kilograms of deviation, which is quite a significant difference from the target. The other thing that we tried to do, because the dairy producers were asking for this piece of information, is how much the feeder errors are costing me. And actually, I realized that to do that is not only to look at the cost of the commodities. If you are spending loading an expensive commodity over the target, that is just part of the cost, but there are also implications, economical implications on losses, milk production losses, just associated with deviations from target. But I did not account for that. What I have here is just deviation from the expected cost of the recipe based on deviations from loading error. So these triangles here represent the median target cost of the recipe, and what we did is just use the data that it was on the feeding management software. They have records of the different costs of the different commodities. So we calculate what was the expected cost of the recipe per day, and we came up with this value. This is the median value, and we did that for the 12-month period. So how much was the cost, applying the cost that it was on feed water, how much was the cost of the recipe that it was prepared compared to what it was expected. So here, for example, we are going to look at dairy number 25. For this particular dairy, most of the time, the cost was above what it was expected. And this is in dollars per ton. And when we go here to dairy number 14, what we see is the opposite. In this particular dairy, they were actually saving money just because of the feeder errors, only accounting for ingredients cost, not for losses in production. So I'm just going to give you a second to think how to picture how will be the errors and deviations from target for dairy number 25 and dairy 14. So here is dairy number 25, is this one. This particular dairy actually was underloading ingredients, and this particular dairy actually was overloading ingredients. What happened is in this dairy, the feeder was a little bit more careful about loading expensive ingredients and pay less attention to less expensive ingredients. So that led to the ration prepared being cheap. So sometimes when we are saying, oh, this dairy is making a lot of mistakes going over the ingredients, we need not to look only to the ingredients that are overweight, but also the ones that are underweight. On this particular dairy, I mentioned before that it was a north-south observation, the facility, and we made this observation when we were checking the feed bank. This picture was taken at 9:10 a.m. and they were fed around 5 a.m. in the morning. And what do you see? Here is the east side of the facility, and it's 9:10 a.m. in the morning, so the sun is rising. And this is the west side of the facility. We have a lot of cows here, and very few cows in the feed bank here. So this picture is taken here. Here is the east side, and you can see that the cows are all here. There are no cows exposed to the sun. And if we look to the other pen, we can see here, this is the west, and you can see that in this dairy, they have these curtains here on the west side to prevent for the sun, but there is no cows on the feed bank and no cows also resting in this line because there is this sun coming through. I believe also this pen could also benefit from having this extra shade. Now we are going to move to the secondary, and it's also a feed store facility with 2,200 cows, and I just marked it with these blue arrows the pens, the location of the pens that were being fed high cow ration, and the feeding center is here. Just some background information. This particular dairyman, we did this visit in February last year, and December 2 years ago. I visited with the dairy producer, and he just told me that the old feeder, that he was 78 years old, finally retired, and 1 year ago he hired a new feeder. So he was having this new feeder working for him for over 1 year. And the hoof trimmer just told him that he was getting a lot of white line disease, and the mixer wagon was probably too old, and they probably needed to do something about it. So when I met with him in December, he was planning to buy a new mixer wagon to solve his issue with the hay processing and KMR preparation, and hopefully also have an impact on lane. So this is the background. So now is first what we do is walk through the commodities. Here are some pictures that I believe speak by themselves. So, and if you are not convinced yet, let me show you this. So the hay processing issues that they are obvious here. When we visit this facility, actually the manufacturer company that was building their box actually lent them one, and they were using a similar mixer box to the one that they got. But when they changed to the one that they was borrowed, the problems were still there. The hay was not processed. So they were hoping in 1 month they will get the new mixer box and the problems will be solved. This is another picture of the recipe, the top 10-stage shaker box. So now the new mixer wagon is here. Everybody hopes the best. Now the problems will be solved. The problems are not solved. So the explanation should be in the new mixer wagon that is not doing the job properly. So what they decide to do is, first they change the kicker. They amplify the kicker. Here is the kicker before, and here is the kicker after. Well, what happens after they did this modification, soon after that, they had to remove the kicker because that expansion actually put too much effort into the mixer wagon to get things mixing, and it didn't work. So what else can they do? Well, what they decided to do next was to change the orientation of the blades. And we have here before and the blades after. And this actually didn't solve the problem either. And by the end of our visit, the last change that they were doing, it was the Mr. Wagon was having issues with the dropping feed, and they were narrowing this space between the inner wall and the outside wall in the mixer wagon, so feed will not get stuck and will flow easy outside when they were feeding. So one thing that also we found on this particular dairy is the preparation time of the recipe was kind of on the end, low end. And here we have our dairy number 14 is this dairy number 2. And in black we have the preparation time of the high carb recipe. On white we have the driving and mixing time. And in gray we have the delivery of feeding time. And we see that there are a huge difference from these particular dairies that are those two that are the lowest ones, and to these ones that are the ones that take longer to prepare, drive, and deliver. Unfortunately, I'm talking about driving, missing, or because we don't know the white box, we don't know if the mixer box is working or not when they are moving from the feeding center to the pen. On some days, we are finding that they are mixing while they are driving. On other days, we are finding that they are not. Most of them, we are finding that they are not driving, but each day is a different situation. So we collect all the information from this dairy and put together a PowerPoint presentation for the dairy producer. And prior to the meeting, what we did is collect the information from the week prior to the visit with the dairy producer to show him the time of recipe preparation of his feeder. So how long it took for the different days on different recipes to get the recipe prepared. So here we have Wednesday, the feeder was off on Tuesday. So we have Wednesdays, Thursday, Friday, Saturday, and Sunday. If you look here, you're going to see the pounds that they were prepared per load. And you see that they're quite similar. But what you also can see is that the length of the bar for the various days and for the various pens is different. And in black now we have preparation, in red the driving time, and in green the feeding. And if you look, for example, Friday, the first 14 and 15, he did everything in under 15 minutes, whereas for this other pen it took him longer, over 20 minutes. So one of the things that also was puzzling this baby is that the hay processing issues were not always happening. They were happening on some pens, on some particular days, but they were not consistently happening on all pens on all days. So maybe one day they didn't have any problem with the hay ball, and the following day they may have 2 or 3 pens having issues. So they were very puzzled about that, and the connection, actually, when we present this information, we thought, okay, this is going to help them to understand that the feeder is doing his job a little bit too fast, and and it has too much variation in recipe in pen to pen, but actually they didn't think that that was the reason, because they couldn't tie the association between different pens and different days. They thought it was coming probably more into the commodities that they were feeding, and the mixer wagon, that it was not performing the job correctly. They keep blaming it on the mixer wagon. So again, I show here this picture. I showed this before, where I show the spread of the data for the preparation time for the recipe. And you can see also there is quite a spread on the time that the various dairies, how long it takes them to prepare recipes. And this may actually have some implications on processing the hay, mixing uniformity. What I don't know is if some dairies may be also mixing overtime when they don't have the knife sharp, so they go over mixing just because they think that they're going to compensate for those knives, just doing that. So there is something we need to study more. Why is this variation happening? Why is, for example, this particular dairy 26, that is 800 cow facility, why this dairy has this spread? Some recipes are prepared in 11, 12 minutes, and some recipes are prepared about 20 minutes. We also evaluate the dropping uniformity throughout the feed bank. We were just trying to see how much variation was in the amount of feed delivered through the feed bank. So at the end, what we did is we set up, we find different places, 10 different places in the feed bank, so they were at the same distance from each other, and we measure 20, so we measure this distance here, 24 inches and 22 inches, and we load that amount of feed that we separate there and weigh that. And here are the results. How much feed was in this area, 22 by 24, and here are the pounds. And the coefficient of variation throughout the feed bank is quite impressive, 59.5%. And there are several pictures also that show, well, the first thing that we can see also is the feeders in this particular dairy, and it's not the only one that we are seeing this. They try to put more feed in front of the cows on the areas where are more cows always eating, and is at the entrance of the milking parlor. So here you can see that he put more feed until here. But also you can see that there are problems here with the flow of delivery. It's not consistent. Loading ingredients. So this figure again represents time between ingredients that are less than 50 seconds, that are between 15 and 30 seconds, that are between 30 and 45 seconds in gray. And we have here our dairy, number 14. And this dairy actually had a poor time between ingredients, but the owner was okay with that. He knew. So sometimes we need to educate the owner first and then just talk to the feeder. And this dairy, this particular dairy, the dairy number 14, was the one that He had a deviation. You can see here that is overweighing. Most of the times he's overloading ingredients. And this dairy 14 is the one that at the end made the recipe cheaper that I showed you in a previous slide, and that's because he was probably more carefully loading ingredients that they were expensive, but the other ingredients that they were not expensive, he didn't try to be as accurate. And I show here now the cost of the recipe per ton. So he actually saved him money. So TMR delivery. One thing that actually surprised me is when you go to a dairy and you ask, how often are you feeding your cows? It's always a very simple answer. It's once, twice, or 3 times. But when you look at the feeding management software data, it actually is not. And in this particular dairy, for example, over 1 month period in dairy in this dairy case study number 2, we have that pen number 5, all the times it was 2 times. The feed was dropped 2 times. If we go to pen 7, it was dropped just 1 time. And this is because this is the hospital pen. But if we go to pen number 13, again 2 times, and pen number 14, 1 time, and there is no excuse, they are all high producing cows. And in this figure, what it represents is the feeding frequency for the 26 dairies that we evaluate feeding management data. These 2 first dairies, they were feeding just consistently, just 1 time a day, so that's why they are in A grade. These dairies here, they were consistently feeding 2 times a day, and then we have these dairies here that are a combination, either 1 and 2, or if we go here, we have 2, 3, and 4 times. So what it means here is that on some days, some pens are fed 1 time, others 2 times, others 3 times within the same day. Here what I have is the frequency that is delivered for this particular dairy that we are studying now, dairy number 2, and using the data from the month prior to the visit. And by sequence, what I mean is the mixer wagon, the load that is prepared normally is split among different pens. So some pens get always the first drop or the first feeding, then the second feeding, and then the third feeding. So sequence actually means from the load that is prepared, if that particular pen is fed the first part of the load, and then the second part of the load, or the third part of the load. And you can see that there is also no consistency. This just indicates you that this feeder didn't have an organized schedule and didn't repeat. And there is more evidence here. Again, I told you before that Tuesday is the day off of the feeder, so of course he comes back on Wednesday to work and comes back late. He's supposed to start around 2:33 and start feeding around 3:34. But this day on Wednesday he started feeding around 6, and then he probably somebody saw him coming late and told him something, and the following day came back a little bit early. But again, go back late. And then on Sunday, because he wanted to come, probably finish sooner, he came early and finished early his job. So you can see him that he's adapting his feeding schedule to his personal schedule. And not only that, we have here the different pens, the pen number 15, 14, 13, 7, and 5. And you can see that he starts feeding sometimes first one pen and then a different one. So he's changing his schedule, his work is not organized. I couldn't understand why he was doing what he was doing. And this is another way to see the same information. To make it your life easy now to see this figure, I just circle the pen number 15. So you can follow that on Wednesday, the pen number 15 was the third one that got fed. On Tuesday, it was the second. On Friday, the first. On Saturday, the third. On Sunday, the first. And then on Monday, the fourth. So this is something that we are finding not only on this dairy, in more dairies, that there are not a schedule. And I understand that they have to work around the milking schedule, and probably it's part of this variation. But we need to understand more what is the thinking process of the feeders when they do the work. Here in this figure, what I represent is the day-to-day variation on first recipe feeding. So what it means is like if you are feeding today at 7 a.m. and tomorrow you are feeding at 8, so there will be 1 hour of difference. So that 1 hour will be 50 minutes and that observation will be here. If the following day you are feeding again back at 7, it means that you are going back 1 hour from the previous observation, so it will be here, 50, minus 50. So what it means is the deviation from the previous day on feeding time. And we can see here that some dairies are very good, are very consistent. They're doing it in plus, minus 15 minutes, 20 minutes. This particular dairy, you can see here that it had an important deviation from the zero. This figure, just what we are trying to represent here on this figure is the time that elapses from the last feeding to the next day feeding. So let's say that you're feeding a pen 2 times a day, and the last feeding is happening at 5 p.m., and the next feeding is happening again at 7 a.m. So basically what we are capturing here is how much time passes from the 5 p.m. feeding to the 7 a.m. feeding. And here we have these two dairies. There are dairies that are feeding just once a day, and you can see here that the time elapsed between feedings, last feeding from one day to the first feeding of the next day is 24 hours. If we go to this dairy, we can see there is around 15 hours time between feedings. The dairies that are making us think are those here that they have a wide spread on time between the last feeding and the first feeding of the following day. And on those dairies, what happens is that some pens are fed 1 time, other pens are fed 2 times, and others are fed 3 times. And we haven't visited, we only visit of these dairies here, we have only visited the dairy 14, that is the one that I'm talking about now. But we need to visit more dairies to understand why they have those disorganized feeding schedules. In my opinion, they are disorganized, but maybe they make sense when they explain that to me. The other thing that also we try to evaluate using the feeding management software data is the pounds that they were fed per cow, per pen, per day, and see if there were variation between pens. One of the reasons because we did that is because we were concerned that some feeders always were feeding first pen number 5, for example, and then second pen number 6. So pen number 6 always will carry over whatever dropping error happened on pen number 5. So we wanted to evaluate if, for example, there was always one pen that was getting underfed compared to another pen that was always getting a little bit overfed. Here what we have is, you can see that these two lines are from multiparous cows, and these two, the blue and the green, are from primiparous cows, and the red dot is the hospital pen. What we are also interested to look is why are these different. For example, these two groups are same production groups. So why this group was fed around 90 pounds and this was fed around 110 on the same particular day? And the same thing, and it almost looks like the pen number 14, the yellow, was always above the black dots. And I didn't do any statistics, and I couldn't find an explanation on this particular dairy of why this was happening, if there was anything to be concerned about it, because the feeding schedule was always changing, and I didn't find any pattern between 14 and 15. So the take-home message here. So through our feeding management assessment, based on farm observations and feeding management software records, we were able to identify some opportunities to improve the feeding process on dairy 1, and the major points on dairy 1 were green chop alfalfa management. Unfortunately, nothing could be done because there was major factors, human factors, relationships involved, and they were not to be disturbed. And then reevaluating the tolerance level assigned per ingredient, and actually that was something that was modified immediately after our visit. In dairy number 2, we suggested to pay more attention to the feeder, train the feeder, explain him the implications of his work. Needed to be some time of response for his arriving, when he was arriving late. So 1 week after we actually were at the dairy, he got 1 week of suspension, but it was not good enough. I don't think he got the message, and actually he was fired 6 months after our visit. So I thought he was going to be fired sooner, but they tried to give him an opportunity, didn't change, they replaced him. And I didn't show you any video of him operating the equipment, but this was a 25-year-old man that he was raising with very expensive equipment. And when we asked him, what would you change about your daily job, or you can ask for something to the owner, what would you ask for? And he just said to patch the hole that it was on the feeding commodity area, because always he was bumping there, and he didn't like to do that. So the goal for the future, we would like to develop a feeding management assessment and monitoring program that can be implemented on dairies. Actually, the assessment that we are now presenting here is a lot of work, and we are just presenting a fraction of the information that we collect, and we hope to streamline this in the future so it can be done in a more time-fashion way. And we also would like to establish benchmarks for the dairy industry based on feeding management software data, and we are finalizing the reports from the initial 26 dairies. But as I mentioned before, this data is only going to be probably good for California, and we probably should get other data because if feeders in Mexico are able to do a better job, maybe we can also promote better practices when we show all producers that other feeders in other areas are able to do it better. Then I would like also to evaluate the implications of feeding management practices on milk yield. What are the implications for particularly this dairy number 2, the days that he was showing up late to work? Were there any implications on milk? And I just waiting for funding. I'm trying to apply for fund to continue that work. And I would like to thank all these people that are here, and I want to add also somebody else, that is Dominic Vega, that is one of the nutritionists I didn't include here in the list. Also, I would like to thank the UC Davis Center for Food Animal Health for providing support for the PhD student, also Fundación Barrier de la Maza. And with that, you have here my email address, and if you have any questions, I will be very happy to address those.
Dr. Silva-del-Rio presentation. Before I open the floor to questions, I want to go over a few details. First, I want to invite our listeners to attend the next webinar to be held on the 8th of July at 6 p.m. UTC. The presenter will be Dr. Randy Shaver, professor at the University of Wisconsin-Madison campus, where he holds a 75% extension and 25% research appointment. His research is focused on applied nutrition of lactating dairy cattle. Dr. Shaver's topic will focus on forage quality with a special emphasis to apply at our farms to improve starch utilization. Save the date and time, Wednesday, July 8th at 6 p.m. Eastern Daylight Time, or UTC-4. I would also like to remind you to come back each month on the second Wednesday for an informative new speaker. At this time, I would like to thank the people who made this possible. Tom Tolucci at AMTS USA and Global, Marcelo Hens Ramos at 3R Lab in Brazil, and Paula Torito in Argentina. Our translators in each location, Paula and Rodrigo in Argentina, and Evelyn in Brazil. We also wish to thank the sponsors of our English language seminar, Ajinomoto Heartland, makers of Agipro L rumen protected lysine, and Virtus Nutrition, manufacturers of Energy 2, Prequel, and Strata. Archived presentations are available at our website. We will start with a discussion of the polls, and then we'll take some questions. We already have some questions from Argentinian audience that Paula will read for us. And if anybody in the English language speaking audience would like to ask a question, please raise your hand or type it in the question and answer section. We will go to the results from the polls that we took, and Dr. Silva-del-Rio will lead us in that discussion. So I'm going to bring up that poll result. There we go. These are the results by country for the first poll, The question was, if you balance a diet for 16%, what is the crude protein of the diet in front of the cows at the feed? Both Dr. Silva-del-Rio will look at those results and sort of give a little bit of insight on those.
Most of the people in U.S. and Brazil chose question C, the response C, and depends on the farm. Variation can be big or small, and I show you that that is probably the best statement that fit the data that I showed you before. And Argentina, most of them, I don't know, we don't analyze TMR. And that is actually true. Most of the people don't know the variation between what is being fed and what is and they don't compare with the crude protein analyzed, or yes, in this case, crude protein analyzed at the feed bank recipe. One of the things that we found also when we did a survey, when we did the mailing survey in 2010 to the dairy producers in California, we asked them what was the crude protein percentage that they were formulating. On most of the cases, they didn't know. They replied numbers that they were not crude protein percentage. So take-home message after that experience is that dairy producers per se, they are not very much occupied in thinking about what they are feeding and if it's deviating from what it's supposed to be.
Okay, thanks. We'll go on to the poll 2. How often do you evaluate forage dry matter?
Yeah, and so the response here, most of the audience responded that the D, when we open the silage. And actually, a lot of times that is what happens is when they open the silage, they take the sample, and that's the sample. And that's the dry matter that they use. I would recommend actually checking dry matter more often, especially all of you that are in climates that rain, is very important. We don't have any study comparing this, but just as a field observation here in California, and it doesn't rain much, but the days that it rains, we are always getting reports that we have more DAs on those weeks. And we are maybe assuming that it's just because we get our forest wet, at the end we are feeding less forest and we have less fiber.
Okay. The answers?
Okay, so now what is the order of ingredients loaded into the mixer box? And the three countries, US, Brazil, Argentina, all of them, they agree that the forest first, then concentrate. There is also an important number of people replying that it depends on the wagon. If it's vertical, follow one order, and if it's horizontal, I follow another. My data I showed you from California dairy producers, they actually, for them, didn't matter if it was vertical or horizontal.
Okay, and then to discuss our final poll 4, how often do you check if your mixer box is calibrated?
So here in this question we have that most of the people reply from Brazil and Argentina, reply question D, we replace pieces of the mixer when necessary and no addition. And in the US we have a combination of twice a year, and we don't check the mixer box, and a small number of US respondents, they say once a year. I think there is an opportunity to check the mixer wagon more often. And we are finding that there are opportunities on the data that we are visiting.
Okay. Thank you for covering those poll results. Now we will open up the floor for questions. I'm going to start with Paula Torillo, and she has some questions. Mute your mic. Go ahead.
Okay. Thank you, Noelia. It was a great talk. Carlos asked us, if you are talking about sampling frequency, Wisconsin University recommends certain frequency in relation to number of animals. Do you think there may be differences in the weight of the sample? Can we have wrong numbers just because of the weight of the sample? Which is your recommendation about that?
I'm not sure, Paula, if I understand weight of the sample, what it means that. Sorry?
He's asking about sampling weight, the weight of the sample.
Oh, okay. So what is a recommendation for sampling weight? That's what you're asking?
Yes.
Okay. Yes, that's very interesting. One thing, Normally we suggest around, it depends also what you use. If you use, what do you use normally in Argentina to check dry matter? Do you have coaster testers, ovens, microwaves?
Everything, microwaves and coaster, I think.
Okay, around 100 grams of samples. But one thing that actually I also like to emphasize is that well, the sample first, it needs to be spread. You don't have to pile the sample because then you're not going to get a good drying. It's going to take more time. If you do microwave, it's the same. If you do oven, it's the same. Don't do a pile. You need to use a bigger pen. I think even more important than the sampling way that you're going to put in the oven is how you take the sample. And I don't know if that was actually his question, or maybe I was trying to read it differently. When you get a sample, getting a representative sample from your silas, that is the number one thing. And for that, you should get 10 to 20 gram samples from the silas that you just defaced and do a composite sample. And what we do in the lab, and I know that this is a lab procedure, and I don't envision any feed manager or feeder doing this, do the quartering method. So we put the sample on the floor, and we split in 4 pieces the sample, and we take apart 2 samples, mix 2, and then we continue until we get the final 100 grams approximately. It doesn't need to be exact, just to be careful not to be over the pen that you're using, that you're not putting too much on that. And I don't know if that is what he was looking for, the question.
I think so. If not, he's going to write us. Okay, I have another question. Okay. Leonardo asked us if you have prevalence values of digestive disorders in relation to the feeder performance.
No, that will be actually very interesting, and it will be a lot of work, but it will be worth to do, because now the next step also will be to rank dairies based on performance and find difference in milk production, but also in animal health. The dairy that I'm talking about, dairy number 2 that I presented the case, they complain about a problem of increased incidence of white line diseases. And we can assume, but I cannot tell you that it was the cause. I don't have any proof that it was related to the feeding management, the reason because they were getting more hoof lesions now. But it could be, and it was a strong suspicion on the dairy.
Yes, I have 2 more.
Okay.
Carlos is asking, do you think we increase errors in feeding as we work with more ingredients?
Yes, because if you add, most of the diets that we have in this database are ranging between 4 and 9 ingredients. That is what we are using, and I don't know if it's something similar what you are doing in Argentina.
Yes, I think it's similar here.
Okay. Well, of course we want to do premixes. That's the reason that's why we do premixes, and we have few days with 9 ingredients, and most of the days are going to 4, 5, 6 ingredients. And that is just because they prepare premixes. And there are advantages of doing that. First, because you probably are going to get better mixing and less error. And the question that Carlos made can be explained very easily if you think about what I explained before about the errors as a percentage versus the errors as a kilograms. So when you are adding an ingredient that is a small quantity and you made a small mistake, as a percentage, it's going to be huge, because we are talking about small quantities that you're weighing. But if you put 3 times that amount and you make the same error, because the feeder error really doesn't, for the feeder, the error that he's going to have is not going to be dependent on the size of the mixer wagon that he's preparing or the load that he's preparing. So making a big load is going to decrease the error when you express that as a percentage.
I have another one from Pedro. He's asking if you think mixer manufacturers should have a more detailed user guide. Here in Argentina, he sees little consistency when we ask them when we have bad mix rations.
I would love to talk to him, and I say yes, yes, yes.
Okay. Yes, I think he agrees with that.
Hi, Paula, did you have any more questions?
Yes, I have a couple more, but I have to translate them. So if you give me a minute, I can do it.
I'm actually going to unmute Tom. I expect that he might have some comments to make,
Perfect.
if not some questions.
Okay.
Okay, so when you were doing all this data collection, in all of your data collection, did you find out how many of the farms had SOPs for feeding, or was it just the guys were hired and told to go feed cows?
The data from the 26 days, some of the backups we got just in the day, we got the backup and left. So we didn't do the step of talking to the feeders, and we are now doing our 6th dairy now. So from the dairies that we are visiting and for the experience that I have from other dairies, the most that I've seen is that they have a protocol for how to do the dry matters on the coaster tester. But when we talk to the feeders about how do you organize your work, how do you feed your cows, I haven't seen any protocol, and if they have any, they have never referred to the protocol that they are following.
How many of the feeders have identified that they feel stressed in time just to get the job done?
I met one long time ago. It actually changes day to day, and I thought, okay, last day they may be more stressed. Or I think you have to look at the owner, and then you know if the worker is going to be stressed out or not. In one particular day, when we visited with this was 4 years ago, he almost didn't have time to talk to us. But like I mentioned to you, this dairy that we visited like last month, the feeder was very happy to talk to us because he was actually getting paid. And at the end, we got the phone call because he was, writing the hours and for the time that he spent with us. So, and the other thing is the dairy number 2 that I presented, the feeder that was showing up always late. Actually, what he did is he will get late from work, and then he will start his job, and because he was behind feeding, he will do his job very fast. He will race, but because he has to check in and out, then after 9, you could see him sitting on the tractor, and he was available to talk and do whatever because he needed his 8 hours of working time, and he was trying to make up time. So I found that already on 2 dairies, and I don't think those are the only ones.
So you're seeing a lot of these feeders in California being paid hourly?
Yes.
That's a big difference because in a lot of other places they're paid.
I think it's because of legislation, and actually the dairy that I visited, the number 20, where the feeder is actually the one that it takes over 20 minutes to prepare each recipe. That dairy had a lawsuit 4 years ago, and they were doing salary, and after that they're doing clock time and paying hours. So I think it's just legislation what is pushing the dairy producers to do that.
Okay, thank you, Tom, for your comments. Paula has a couple more questions from Argentina. Because Marcelo is on a beef cattle tour this week, he is not able to join us, and so there are fewer questions from Brazil than usual. So, Paula, I'm going to unmute you, and if you would ask a few more questions.
I have 3 questions more. Leandro asks, do you have milk yield values comparing 1 versus 2 feedings in a day?
No, I don't.
Okay. Are there differences in mixing homogeneity comparing a standing mixer versus a moving mixer? This is a question from Marco.
Yes, I haven't compared, and there are actually, there is a huge need to do more studies on mixer performance, mixer uniformity. I actually like more the standing ones. They have, of course, less bouncing, but if they perform better or not, I have never checked that.
Okay, and the last one from Carlos.
And just another comment, sorry, Paula, that in California, I only know one dairy that I know that there are many more, but of the clients that I normally work with, there is just one that has a standing one. They are not very popular right now.
To start monitoring rations, do you think it's valuable to look for uniformity in particle size distribution first?
Particle size distribution. I didn't present the data, but I'm actually, and you probably are familiar with what Diamond Bee is doing. They are evaluating mixing uniformity using the shaker box.
Yeah.
And they're doing that on farm. And the advantage of doing that is that you get immediate feedback, and it's cheap, and anyone can do that. I'm actually doing that both sides, the wet chemistry and the particle size separation from Penn State. And it happened a couple of times that I find variations in one of the screens, but when I look at my wet chemistry, so far I was not able to find a coefficient of variation higher than 3% looking at 10 different samples in the feed bank.
Okay, and don't you have correlation values?
Yeah, I look at, my sample size now is very small, but I have both the Penn State and the wet chemistry, and I don't have any problem to share that information. And in both cases, we didn't have issue in any case. So we haven't evaluated yet a dairy with important issues on feeding uniformity. Maybe when I have one case with issues on feeding uniformity, I will let you know more. Actually, I'm working right now on close-up diets, and the reason is because we have this huge, we are evaluating close-up diets because the close-up diet is like 20% of the mixer capacity, or 40%. There are around 20 to 40%. So if we have missing uniformity issues here, we should look at those. And I am starting to look at that information. And if anyone is interested, they can email me. And when I have more information, I can share that. And I'm doing both the wet chemistry analysis and the Penn State.
And for wet chemistry, what are you looking for? Crude protein, NDF?
I do the regular panel, and for the close-up diet, I'm also adding now the anionic salts.
So, Dr. Silva-del-Rio, I think that concludes our questions for this particular session. Thank you so much for your great presentation. And I want to thank Paula and Marina on behalf of Marcelo for his presentation. We will have of this webinar up on our website within a couple of weeks. And
Vamos a tener una grabación del...
And in that recording, when I send the email out to all the participants, I will make sure to include Dr. Silva-del-Rio's email address so that anybody who wants to contact her with questions can do so. Again, I want to thank everybody for participating. I apologize for a little bit of the audio problems we seem to be experiencing tonight. It seems to be endemic when we have heavy rains in our area, and it has been a very wet week. So hopefully that won't be a problem in the future. Dr. Silva-del-Rio, thank you for joining us. I'm going to unmute Paula and Marina so that they can also thank you, and then we will sign off.
And thank you to all of you for inviting me. It was a very good experience. I hope to get questions and emails.
Okay. Paula or Noelia, thank you very much for joining us. And everybody, thank you for joining us for this webinar. At this point, we will say goodnight. Thank you. Goodbye.